All right, in this lesson we are going to identify constant rate of change, and provide evidence of it. This time we're going to be given a table, or you'll see. So, I gave you some examples, 3 examples of constant rate of change that show up in tables. So let's look at this first one. We have the grapes measured in pounds, and the amount of grapes measured in pounds, or the weight of grapes measured in pounds, really, and the price of the grapes. So we can see that the price increased by $1, by $1, by $1, by $1. The grapes were increasing by $1. The price of the grapes was increasing by $1. Every time the weight of the grapes increased by 2, so plus 2 pounds, plus 2 pounds, plus 2 pounds, plus 2 pounds. So I'm going to say that again. The price increased by $1 for every 2 pounds of grapes. $1 more, 2 more pounds of grapes. $1 more, 2 more pounds of grapes, and so on and so forth. Let's look at the time and temperature on this one right here. The temperature is decreasing by 5 degrees, by 5 degrees, by 5 degrees, by 5 degrees. When the time increases by 2 minutes, 2 minutes, 2 minutes, 2 minutes. So the temperature will always decrease 5 degrees every 2 minutes. And finally, let's look at example 3. So example 3 is slightly different because it's a horizontal table, but same concept. So we have the number of tickets and the cost. So we can tell that the cost increases by $5, $5, $5, $5 every time the number of tickets increases by 4 tickets, by 4 tickets, by 4 tickets, by 4 tickets. Now, let's go ahead and dive further into this. So, to start off easier, I just put X and Y. So, when you do this, I always want to see this. I always want to see this. So you're going to write triangle Y. That means change in Y. And you're going to write triangle X. This means change in X. Let's talk about the way that Y changes. So from here to here, the Y increased by 2, the Y value. From here to here, the Y increased by 2. And from 5 to 7, in order to get from 5 to 7, the Y increased by 2. Now let's see what the corresponding changes in X are. So when the Y increased by 2, when the X increased by 5. When the X increased by 5, and when the X increased by 5. So over here, I want you to write change in Y over change in X. That is our constant rate of change. The change in Y, so it's plus 2. So we'll just do it like this. It's a 2. We'll do it like this. That's a positive. It's going to go over a positive, and a positive over a positive is a positive. So it's going to be 2 over 5. If that confuses you, we'll do it like this, actually. Let me back up. So a positive 2 over a positive 5, and a positive over a positive is a positive 2 over 5. Okay, so it's not always going to show up this way. If you noticed, we skipped some numbers here. If you notice, we actually we increased by 4 here, and then we increased by 6 here. We increased by 10 here, and then we increased by 15 here. So let's see if these also work. So let's do positive 4 over positive 10. So positive 4 over positive 10. Positive over positive is a positive. So I'm going to box these so I can just see them. And then we have a positive 6 over positive 15. So I'm just going to do this part ahead of time. So a positive over positive is a positive. Then we have 6 over 15. And let's go ahead. Well, I guess we can box this one too. Let's prove that 2/5, 4/10, and 6/15 are equivalent. So 2 divided by 5 is 0.4. 4 divided by 10 is 0.4. You'll have to check each of these. And 6 divided by 15 is 0.4. These are all the same, they just look different. You could either show it like this by showing the division, what the answer you get with division, or if you want, you can also show equal, like how you would get equal fractions. And then times 3, and that's times 3. You don't have to show the arrows and this unless you want to. The easiest way to show you is just by looking for the unit rate. So just by 2 divided by 5, 4 divided by 10, 6 divided by 15. So let's talk about the easiest one, the simplest one. So y value increases by 2 when the x value, when x increases by 5. All right. And lastly, before we finish this problem, let's just put our unit rate. This is 0. These all equal 0.4. So equals 0.4. I'll put that in the center. 0.4. Now, if you can see here, I skipped these numbers in between, right? Like I went to 0, I went to 5, 10, 15, but then I jumped to 25. If that seems weird to you, then we could technically do 0, 5, 10, 15, and then it would be 20, 25, 30, 35, 40. And let's count this. So 1, 3, 5, 7, 9, 10, 11, 12, 13, 14, 15. You see how this like fits? Like, it's fine. I just didn't write these middle numbers. So I wanted to show you the exact same, well, not exact, but pretty much the same problem. I'm just going to show you how it's going to look usually. So right here, so I'm going to write change in y, and I'm going to write change in x. The y increases by 2, the y increases by 2, the y increases by 2. But you see here, it increases by 4, and then it increases by 6. Don't be thrown off. This doesn't mean it's wrong. It just means that it didn't leave space for these blue ones. It just skipped from this 15 and 7 to 25 and 11. That's okay. It doesn't need to show everything. And the corresponding change in x's are plus 5, plus 5, plus 5, plus 10, and plus 15. Now let's clean up the last problem because it's pretty much the same, but let me show you how I want you to see it more, okay? So change in y over change in x. So we can just do this. A positive over a positive is a positive, okay? 2 over 5. 2 over 5. That's good. Let's just jump to the next one, next different one. So a positive 4 over a positive 10. So a positive over positive is a positive 4 over 10. And right here we have a positive over positive again, which is 6 over 15. If you write this, this is a good start. You don't have to put the pluses and minuses unless it helps you. So 2 over 5, I'm going to check it, 0.4. 4 over 10, 0.4. 6 over 15, 0.4. So all of these equal 0 and 4/10. And that's how you would show that they are all equivalent. So the y increases by, let's put the smallest one, by 2 when the x increases by 5. So I'm going to show this one and the last one that we did real fast. So in this problem, I showed you that you could show the arrows, you could show the division, that you could fill these in if it helps you, but this is the same problem, but this is also how you could show me. It's a lot easier. Don't forget that if you would like to, you could show these like instead of the 0.4, if you prefer. Times 3, if you prefer. Most people are going to want to just write these decimal down because it's a lot faster. And because they have to write it at the end anyways, like you have to write the 0.4. So they just prefer like to check them anyways. Because this way, with the times, sometimes it gets like you don't know what to multiply by. So if I were you, I would just do the orange part right here, and then you'll be good to go. Let's look at page 2.